Gravity. An idea born in the 1600s when a young man named Isaac Newton was presumably hit in the head by a falling apple. Now he might have just observed an apple falling, or the apple fell on someone else's head. Whatever happened, it made him wonder why all apples fell, down. Why don't they go up or sideways? And holding an apple, you apply a friction force on it, but you do feel its weight. And when you let go, it falls. This made Newton think there must be a force acting on the apple, and on everything else for that matter, the force of gravity. Of course, then came the Equivalence Principle, stating that all objects fall in the same way. Here is the case of a heavy ball and a feather falling in a vacuum, which proves that it's the air friction that makes a feather fall slower, an idea predicted by Galileo in the 16th century with his famous experiments rolling balls on inclines and dropping objects from the Tower of Pisa. Yeah, people use that tower for more than weird poses that are so common nowadays. Later came general relativity, a concept we've all heard about, but very few understand it, probably because it was conceived by one of the greatest minds ever, Albert Einstein. Now it depends on what phenomenon you're trying to explain. If you're studying a ball rolling off a table, then Newtonian mechanics is more than enough. If, however, you're looking at particles going around a particle accelerator, since their speed is just a smidge lower than the speed of light, you most certainly need a relativistic approach. Now, the so-called scientist is trying to prove there is no gravity using his understanding of the scientific method.
This is my parts per million counter. This is going to measure the parts per million of both these fluids. This is tap water, regular tap water. That is the same tap water, but it's been preloaded to save some time with some salt from this.
Since his experiment consists of an egg, a glass of water, and some salt, we will stick to Newtonian mechanics and similar experiments, as bringing up the existence of gravitational waves really seems a bit of an overkill.
Today's video will be doing a little bit of science, and we will be observing how we can manipulate the medium by changing the density and create a force. Newton said, where there is an acceleration, a force must be present. Today's video is all about science.
And I know that YouTube is full of these so-called debunking videos of gravity, but since this one claims to make use of the scientific method, I thought it deserves some actual scientific treatment. Now I won't show you the whole video, as it is over 20 minutes long, and half of it consists of web pages from his research and scientific sounding ideas unfolding over his inspirational portrait. But I will link it in the description below if you're curious, and I'll just show his conclusions here.
That egg moves, I've caused it. We know the parts per million is about 300. All we need to do is pour some of this in. Hey, what do you know? The eggs immediately moved. Didn't have to wait for that, did we? If you assert that gravity in any way caused something in this experiment, that means you are adding a secondary cause. Adding by inference. If you add a secondary cause by inference, you fall outside of scientific method because you can't infer an extra cause when you've already got one that you've manipulated.
The whole idea is centered around the variables involved in a scientific experiment, which are just the things that are changed or measured by the scientist. In simple terms, there are three types of variables, and I will describe each using this simple DC circuit example, where we want to measure the current as a function of voltage for a given resistance. The independent variable is the one changed by the experimenter, so it is the voltage in this case. Now, our sleeping through physics classes warrior claims that you can only have one of these, as adding another would be against the scientific method. Well, not really. It's just that it's way easier to have only one to play with and then one to measure. And he even shows this in his video, unwillingly I suppose. The dependent variable is the one that's measured upon changing the independent one, or we measure the current when changing the voltage. And the control variable is the resistance in this case, or the variable the scientist prefers remains constant throughout the experiment. But we could swap the resistance with a variable resistor, which implies the resistance now becomes an independent variable along with the voltage. Does this mean we can no longer verify Ohm's law? Or that we're falling out of the scientific method? No, it just makes things a bit more difficult for us. Other such examples of multiple independent variables experiments are varying the pressure and temperature of water and studying its state. Or we could also graph how many people are college educated as a function of age, gender, and country. Going back to his experiment, yes, he changed the density of the water, But unknowingly, he also increased the gravitational pull on the water by increasing its mass with salt. So according to his claims, this experiment is not within the scientific method. And on top of all that, what he proves here is that the buoyant force, also known as Archimedes' force, is density dependent. How does that exactly tell us there's no gravity? If you'd ask me, gravity is actually the reason behind this buoyant force. But for the sake of argument, let's just assume that he's right about the variables conundrum. The next step in the scientific model is the peer review process. So Mr. Sleeping Warrior, I will now ask questions about your findings.
Newton said, where there is an acceleration, a force must be present.
So basically it doesn't move unless there's a force present. Okay, it moved. What force is this? Could that be gravity? Or do you just take out whatever works for your hypothesis and then disregard the rest? It goes up and then it stops. Why? If we take gravity out of the picture, what's holding the egg from going up with your newly created force? If there is no gravity and objects fall because they're denser than others, why do they go down? Why don't they go up or sideways? And I also have a simple experiment. I fill this glass to the brim with water and put a coaster on top. Now both the coaster and water have larger densities than air. Why don't they fall here? I can easily explain this with gravity. How can you explain it? I have a video where I describe the whole gravity/buoyancy situation and provide answers to the previous questions. That is if you'd like to know the more complete scientific explanation of your experiment. The way I see it, the situation is like this. You are hopefully confused and don't really know what you're saying, which is not too bad as the scientific model can be tough. I truly hope we're not in the situation where you actually know you're wrong, but still decide to publish your video, because that would make you a manipulative wannabe liar who purposefully contributes to this anti-vax global warming skepticism and flat earth deception wave. The choice is yours, Sleeping Warrior.